Hello everyone, we're going to start today off with a couple review problems. So I want you to pause the video. This is exactly what was on the Unit 3 test under some of the solving equations. So I want you to pause the video, go ahead and solve this, and then see what you come up with. Okay, so if you need more time, just pause the video again. But in this case, what we want to do is isolate the radical that has more stuff underneath it. So I'm going to add radical m to both sides. So we're going to get radical m plus 6 is going to equal 2 plus radical m. Now when we go to square both sides, I don't just square the 2 and square the radical m. I have to square the whole quantity. So if you guys remember, on the left side, this will just become m plus 6. But on the right side, it becomes 2 plus radical m times 2 plus radical m, and we need to distribute 4 times. So in doing this, first I multiply 2 times 2, which is 4. On the outside, I'm going to get a plus 2 radical m. On the inside, I'm going to get a plus 2 radical m. And then at the end, radical m times itself is just m. Now these m's, this m over here and this m over here, can cancel out. We can just subtract an m from both sides. Let's write what we have left. I've got 6 is equal to 4 plus 4 radical m. Now I want to get the radical m by itself, so I'm going to subtract this 4 from the 6, so that's 2 is equal to 4 radical m. I'm going to divide both sides by 4, so 2 divided by 4 is a 1/2. That's equal to radical m. Next, I want to square both sides to get rid of that radical around the m. If I square 1/2, that's going to give me 1/4. So m is going to equal 1/4. Now we're going to check this. We don't really get too many fractions as answers for these. But let's go ahead and say we have the square root of 1/4 plus 6. I'm just going to write 6 and 1/4 is going to equal 2 plus the square root of 1/4. Now for this, if you need to use a calculator, we could say 6.25. This is going to equal 2 plus 1/2. So if on your calculator you take the square root of 6.25, you do get 2.5, which is equal to 2 plus 1/2. That's 2.5. So that checks. Now in some of the problems from Friday's assignment, we have to know how to factor. So first I want to, because one of the problems I believe comes back to something like this. So if we expand this, just like what we did in the last problem, it means the quantity a plus b times the quantity a plus b. So give this a try. Go ahead and multiply everything together and see what you get. All right, hopefully you're getting the a times a first, so a squared. On the outside, we get an ab. On the inside, we get ba, or we could also write that as ab. And then b times b will give us b squared. So now we're going to get a squared plus 2ab plus b squared. I believe it was in problem number 6, you were given this, and we had to know how to factor it like that. So next, I am going to go over all of the problems 1 through 8 from Friday's assignment. So please go ahead and get that assignment out, and you could check your solutions. So today we're still doing the same thing. We're simplifying rational expressions, and we still want to be able to state restrictions of a rational expression. So first, if you just want to check all your answers, and then I will go over each one. All right, so let's take a look at number 1. We were given the quantity x plus 2 over the quantity x minus 5. This cannot be simplified. We cannot factor anything. The only thing we could do is state restrictions. So this x in the denominator cannot equal a positive 5. If it did, we would get 5 minus 5, which is equal to 0. All right, for number 2, we have 14m squared over 2m cubed. Now these are both monomials, one term, so there's nothing to factor. So before I cross some things out, because it can be simplified, I want to go ahead and state restrictions. So I only have a monomial, or since we have a monomial in our denominator, the only value this m cannot be is 0. So I'm going to write here m cannot be 0. And then we simplify this. We could divide the 14 by 2. This is just going all the way back to when we simplified powers with exponential expressions. So 14 divided by 2, those are coefficients, so that's going to give me a 7. And then where do I have more m's? In my denominator, how many more? Just 1. So now number 3, we have 3r over r squared plus 6r plus 8. So our denominator can be factored. We'll leave this as a 3r. This can factor into, make two sets of parentheses, r and r. Everything's positive, so we'll put plus signs. And then the factors of 8 that can add to a 6 are 4 and 2. So nothing can cross out, but even if something did, I wouldn't cross it out just yet. I'd have to state my restrictions. This first r cannot equal a negative 4. The second r cannot equal a negative 2, but it cannot be simplified. All right, number 4, we have 2x over the quantity x squared minus 1. Again, my denominator is the only part that could be factored, and that'll factor into two sets of parentheses. This is a difference of squares. We could factor it into an x minus 1 and an x plus 1. Like number 3, we could factor, but nothing crosses out. My restrictions, this first x can't equal a positive 1. The second x can't equal a negative 1. Now for the directions for 5 through 8, it does say assume no denominator is equal to 0. So that means we don't have to worry about restrictions. So for number 5, all we have to do is factor and cross out. So for 5, we have x squared plus 4x plus 4 all over 4x plus 8. We can definitely factor both the numerator and denominator. The numerator factors into two sets of parentheses. Factor an x squared into x times x. Everything's positive, so I put plus signs. Factors of 4 that can help me add to a 4 are 2. So I get an x plus 2 times an x plus 2. The only way to factor a 4x plus 8 is to factor out a 4. Then we have x plus 2. Again, I don't have to state restrictions, but what can cross out? Only one x plus 2 from the top with one x plus 2 from the bottom. So we're left with x plus 2 over 4. Let's take a look at number 6. Here we have a squared minus b squared. This is definitely a problem that we would not want to try to state restrictions. But if you notice, here's that a squared plus 2ab plus b squared. That was one of our warm-up problems. So when we do factor the numerator, that's going to factor, this is a difference of squares. It's going to factor into two sets of parentheses. We'll have an a plus b in one and an a minus b in the other. In our denominator, remember when we multiplied a plus b times a plus b, we got this denominator. So to factor it, we go back to the a plus b times a plus b. So now one a plus b from the top is only going to cross out with one a plus b from the bottom. We only had one a plus b in the numerator. So now what we're left with is a minus b over a plus b. Now these look like they could be opposites, but the a's aren't. If this said b minus a over a minus b, then those would be opposites. Let's take a look at number 7. We've got x squared minus 1, that looks familiar, over x plus 1 squared. So we can just factor the numerator into x minus 1 times x plus 1. The denominator technically is factored. We're just going to write these out side by side, because that's what that means. So like before, we could just cross out an x plus 1 from the top with only one x plus 1 from our denominator, and we're left with x minus 1 over x plus 1. And then last, we'll take a look at number 8. We have m squared minus n squared over m plus n. We have another difference of squares in the numerator, so that's going to factor into an m minus n and an m plus n over m plus n. So now just the m plus n's cross out, and we're just left with m minus n. All right, so let's practice some more of these, and your assignment will be to finish that worksheet from Friday. Please go ahead and copy down number 1. All right, so for this problem, it does tell us to state any restrictions. So we're going to factor, state restrictions, and then cross out. So from the numerator, first there is a GCF. I could factor out a y cubed. What am I left with after I do that? A 3 minus y. Once you guys to pause the video, go ahead and factor the denominator. First look for a GCF. Okay, hopefully you were thinking 2y squared. We want to take out the most factors of y that we can, so it would be a 2y squared. So what's going to be left? We're going to have a y, because 2y squared times y is 2y cubed, minus a 3, because 2y squared times a negative 3 is a negative 6y. So let's state our restrictions here. First, the easiest part is to go to this y. So that y cannot equal a positive 3. Then we have a monomial. So this means y cannot equal 0. Whenever we see a monomial, it's just y, that variable cannot equal 0. All right, so now we're going to cross out. I can cross 2 y's out from here with 1 from the top. So now I still have a y left in the top. Now if you notice, the 3 minus y and y minus 3, are those opposites? Yes. So when I cross those out, I'm going to leave a negative 1 up top. So now my final answer is going to be a negative y over 2. That's all that's left. All right, for number 2, we're going to assume no denominators equal to 0. So this means we don't have to state restrictions. Now we haven't done this in a while, but this numerator, this is actually a difference of 2 cubes. So we have to go back and remember how to factor that, but go ahead and copy the problem down. So I'm going to write this off to the side here. If we have a cubed minus b cubed, if you remember this, we factor into a binomial, then a trinomial. What goes in here first? A and b, we take the cube root of each term, in the same sign. Remember, I'm going to spell out SOAP here. The S stands for the same sign. Then I ignore the a cubed minus b cubed. Now I'm going inside the parentheses here. So first I multiply a times a, so I'm going to get an a squared. Next is the opposite sign, so now it's a plus sign. Then I multiply a times b. Then always positive at the end. Then I multiply b times b. So that's how we factor a difference of cubes. So now when I'm trying to factor the m cubed minus 8, I'm going to make a binomial set of parentheses and then a trinomial. Cube root of m cubed is just m. Cube root of 8 is 2, same sign. What goes in the trinomial? First I square m, or multiply m times m, so m squared. Opposite sign, so a plus. In the middle I multiply m times 2, so 2m. Always positive. Then I multiply 2 times 2, which is 4. Now if you notice, that denominator says it as well, because we actually can't factor the m squared plus 2m plus 4. So that's what's going to cross out. These trinomials match perfectly, and we are just left with m minus 2. All right, so we did some more practice with simplifying, some more practice remembering special types of factoring. So I want you guys now to go ahead and work on problems 9 through 16 off of Friday's worksheet. As always, take care. Let me know if you have any questions.